Often we're interested in adding up the terms of a sequence, and I'm going to introduce this idea with a classic story, or legend, I guess. Maybe it's an urban legend. I'm not sure if it was true or not. But what happened was there was this mathematician, one of the most gifted mathematicians, named Gauss. And when he was a young kid, legend has it, he was like in first grade or something. I guess he was misbehaving in this class, and his teacher said, "Oh, as a punishment, you have to go in the corner, and you're going to spend the rest of the day adding up the numbers from 1 to 100. So what's 1 plus 2 plus 3 plus 4, all the way up to 100. That's your punishment. So go over in the corner." So she probably thought it was going to take him, the rest of the day. He came back in probably 30 seconds with the answer. And so the question is, how did he do that so quickly? They didn't have calculators back then. Well, this is what he did. He said, all right, well, the sum of the first 100 terms, I'm going to write it like this. The first 100 terms, S little 100, is equal to, well, it's equal to 1 plus 2 plus 3 plus 4, etc., all the way up to 100. And then he said, well, yeah, but it's also equal to 100 plus 99 plus 98 plus 97, etc., all the way down to 1. And then he said, I'm going to use a little algebra here. If I add these two equations, I get two S's. Two of those S's is equal to, well, 1 plus 100 is 101, and 2 plus 99 is 101, and 3 plus 98 is 101, and 4 plus 97 is 101, etc., and 100 plus 1 is 101. And so then he said, well, all right, it's pretty clear that this is equal to, well, there's definitely 100 of them. I'm adding up 100 101s. And now if I just divide this equation by 2, I'll get that the first 100 terms is equal to 100 times 101 divided by 2. And just in case you're curious, that's 5,050. So it's equal to 5,050. I'll just write that up here in the corner. So that's a sort of just one example of this guy's genius. He's arguably one of the most gifted mathematicians who ever lived. But I draw your attention to this example because what he did was he added up an arithmetic sequence. So 1, 2, 3, 4. I know it's a boring one, but it is an arithmetic sequence, right? Where your common difference is 1, your first term is a 1, and he's adding up all the way up to the 100th term in this case. So we're just going to examine his little formula here, because what we're interested in is a formula for the nth. The sum of the first n terms is what I should say. So let's just examine what he has here. I'm going to write this as 100, and really that 101 came from adding up the 100 plus the 1, but that's just the first term plus that last term, and then we divide it by 2. So let's just point out what these are. This is the number of terms. Right, she wanted him to add up the first 100 terms. This here is my first term. This here is my 100th term. And there it is. So in general, if I give you an arithmetic sequence, again, this only works for arithmetic sequences, and I ask you to add up the first n terms, you'd say, okay, well, that's just n. I need to know the first term. I need to know the last term. I'm going to add those up, multiply by n, and divide by 2. And there it is. All right. So let's look at two examples other than this one, since I don't want to confuse you with how basic these numbers are, but you can appreciate that man's brilliance. All right, so find S sub 6, the sum of the first 6 terms. of the arithmetic sequence whose formula is this. So we know that the first six terms added together is going to be n, 6, and I need to know my first term and my sixth term. So my first term is 2 times 1 plus 1 is 3, and my sixth term is 2 times 6 plus 1 is 13, so it's 3 plus 13, and this equals 6 times 16 divided by 2, which turns out to be 48. Alright, if you want to pause the video and try this one, you can, but the sum of the first 11 terms, in this case, would be 11 times my first term plus my 11th term. In this case, my first term is a negative 3, and my 11th term is a negative 53. Alright, so this equals 11 times negative 56 divided by 2, and that is equal to, oops, keep messing up here, negative 3 plus negative 53 equals negative 308. Alright, so there you have it, a formula for the sum of the first n terms of an arithmetic sequence. Again, remember, this only works for arithmetic sequences.